All right, so we're going to work on question number 3 from the Unit 7 Worksheet 8 Molecular Polarity Worksheet. This one, I did see some people struggling with this one just a little bit, so we're definitely going to want to focus on this one. All right, so I'm going to start by identifying the number of valence electrons that this problem has, and we're looking at OF2. So I have my oxygen, wrong color. I have my oxygen, and I have fluorine. One oxygen has 6 valence electrons. 2 fluorines times 7 valence electrons is 14 valence electrons. So 6 and 14 is 20 valence electrons. So I'm going to start with my central atom, which is oxygen. I'm going to take fluorine, put it on either side, and then I'm going to go and draw a single bond in between. So 20 minus 4 is 16 valence electrons. And in this case, I'm going to start placing pairs of electrons around all of my atoms until I've used up all 16. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, so that's the most properly drawn structure for OF2. And the most common mistake that I saw as I was walking around today was students were trying to make it a double bond and a double bond. And then they didn't have any dots on oxygen. So one of the things that I kept saying to students is that if we can draw the structure where each atom has 8 valence electrons using single bonds, that's the way that we always want to do it first. Okay, so now we're going to go and calculate the bond polarity. So we have oxygen and we have fluorine. Fluorine has an electronegativity of 4.0. Oxygen has an electronegativity of 3.5. So 3.5 minus 4.0 is 0.5. So that makes this a polar bond. And then the next thing we want to talk about is we want to talk about the Vesper geometry. And I did see a bunch of students kind of make this the wrong guess or the wrong answer here. So there is an A, which is your oxygen. Then we have X2, which means that there are 2 atoms, 2 fluorines bonded to the central atom. And then there is an E2, which is the oxygen has two pairs of dots. So A2 or AX2E2. I'm going to go back up here and take a look and see that. So it's either going to be linear or bent, because those are the 2 options that have 2 atoms bonded to the central atom. It's not going to be linear because there's nothing else on the central atom. So it means it has to be bent, because bent has the unshared pairs of electrons on the central atom. And in the notes, we said that there could be an instance where there were 2 sets of unshared pairs of notes on a bent structure. So that tells me that this structure, its Vesper geometry, is going to be bent, or not bent, not tetrahedral. Now, in this instance here, because it's polar, right, we do have to draw our dipole arrow, and we're going to draw our dipole arrow toward the more electronegative element. So it's going to look something like this. And then we are going to, because there's a dipole arrow, we also have to put in our partial charges. So delta positive, delta negative, delta negative, delta negative, and then our oxygen is going to be delta positive. And then the molecular polarity with the explanation. So in this case here, the electrons are both being pulled away from oxygen in equal and opposite directions, so the arrows cancel out. However, this is still going to be a polar molecule. And it's going to be a polar molecule not because the electrons, the dipole arrows, are canceling out, but because of the 2 pairs of unshared electrons on the central atom create a large area of negative charge on the central atom. So not only is it a polar molecule because it has two pairs of unshared electrons on the central atom, but those two pairs of unshared electrons on the central atom create a large area of negative charge on the central atom, and that's the complete explanation you're going to be needing to write. All right, so that's the answer for OF2.